Okay, I think we are ready. So, hi everyone, welcome. Give everyone a chance to get into the room. Thank you for joining me today. Um, so I'm working on two screens, so you guys may be seeing me look at two different ways. So I'll do my best to look at the camera. But today we are going to be talking about blockchain. And Jody just shared a resource that I have for you guys today. That resource is just basically a handout that starts with a glossary, and then it has an overview of how blockchain works, and then some use cases, which we're going to talk about today. But we are going to start this session with a game. So just because I like to challenge myself and challenge all of you to actually learn through gameplay. So I want to say hi to everyone. So before we get into the game, and so this game's going to be a little bit different than most games. We're not going to jump into Mural just yet. I am using Mural. I will have you jump into Mural after the game so we can do some basic discussion. Okay, guys? So let's start with the basics. So because blockchain is so new, I want to start you off with kind of a glossary of key terms that we're going to use today. So blockchain, who can tell me in the chat what you think or you know blockchain to be? Just really quick, just type it in there. Let's see. Anyone in the chat, if you can just type what you think blockchain is right now. Let me give you a few seconds. Hello. A ledger of immutable transactions. Good. Those are some big words, right? Ledger, immutable transactions, digital tokens, secure handoff or traceability, an ongoing ledger of transactions, digital currency, immutable ledger. No idea. Okay, that's fair, right? Okay, so let's start with blockchain is actually, think of it like a checkbook. Remember the check registers that you used to get whenever you open a bank account? Some of you may have never had a checkbook, but think of it as a place where you enter information. And transactions are things like buying, selling, swapping, trading, gifting, digital assets when we talk about blockchain. Here on the screen, I have some basic terms that we are going to use today because, as I mentioned, we're going to play a game, and I promise I took all of the math out of it for you, but we are going to do some basic mathing. I'm going to keep it really super simple for you guys as a way for you to see how blockchain works and what we mean by immutable. So immutable means unchangeable. So you can't change it. And we'll see in our game how the blockchain is immutable because that's so abstract, right? So let's start with these glossary of terms. So we have a few terms we're going to use. So an actor. So an actor is basically someone that's actually engaging in the transaction of selling, swapping, buying, granting a digital asset. The blockchain is made up of blocks. And a block is basically a discrete set of data. So it means it holds, like, think of it like a box that just has data in it. And that data is the transaction information. Then we have hash. The hash is an encrypted key. So it's a secret encrypted key that's really hard to break, which is why what makes blockchain kind of secure and immutable, because it's really hard to crack a hash once it's created. Mining. So you guys may have heard the term about crypto miners and people who spend all their time mining and making money off of mining cryptocurrency. So mining isn't only for cryptocurrency. Mining is for anything on the blockchain. So it's how those digital asset transactions, those records, are actually added to the blockchain. So they have to be validated. There's something called a consensus method, which we will experience during this session, where all the miners and all the nodes in that mining group have to agree that there's a puzzle piece that needs to be solved and that it's solved correctly. Nodes, as I mentioned, is computers. It's just a group of computers. And then we see public key and private key. So think of your public key as your username and your private key as your password. That's the easiest way for me to share with you as to like what those two terms mean. And those two terms are the terms that are most used by anyone that's involved in crypto currency, or just trying to create assets on the blockchain. There's one other term that I don't have here called smart contracts. So smart contracts, they're not legal contracts, but they're, if you've ever signed a contract anywhere, a smart contract works like a regular contract, except it's digital and it automates a task, and it's not a legal contract by no means. So with that level set there, these are the core terms that I want to share with you today. In the handout that Jody put into the chat, Jody, if you can share that link again, just for those who have joined because it's moved up. In that chat, you have a full glossary that you can reference for, post session or during the discussion if you have questions about that. So now what I want to do is I am going to stop sharing for a second because I want to get my next link for you. Let's see if I can stop sharing here. I haven't been successful in this. Okay, so I'm going to get the next link for you so you can play along in a game, because we're going to play a game. It's going to be a Google Doc, and what I want you to do is I want you to download the Google Doc and open it up. I'm sorry, because it's going to be an Excel spreadsheet. Sorry, not a Google Doc. What I want you to do is I want you to download it and I want you to open it. And I'm going to open mine so you can see what this looks like, because we're going to go through and we're going to play this modified version of a blockchain game that I created. Let me just open mine up. I'm going to bring my screen up and I'm going to share again. So just bear with me for 2 seconds. And I'm going to ask all of you for your forgiveness on any technical issues that we may encounter, because I always kind of push to try new things. And so hopefully this will go off without a hitch. So if you download that spreadsheet that I shared with you, this is what we are going to consider our blockchain ledger. Let's see, and I'm going to try to make this bigger for the share. It's not letting me. Okay, so give me a second. Let's see if I can make this bigger. There we go. Okay. So your ledger is going to look something like this. And down here is a decoder. So in this game, what I'm going to do is I'm going to share with you some transaction information. And in that transaction information, there's going to be information that you're going to enter into the ledger. So let me just organize my screens here so we can see both at the same time. All right. So I'm going to do the first transaction with you because I want you all to follow along. And what I want you to take note of is how the information is entered into the ledger, into your ledger. And then there's a puzzle that we're all going to solve. So I'm going to give you columns C, D, and E, the information that goes in there. And then you're going to fill out columns F through J only. Column K will automatically calculate for you, and column L will turn green or red. Red means that you're the digit that you're looking for is wrong. Green means it's right, and that's going to be based on this number here, this nonce. So you're going to pick a number between 1 and 3. Here's a random number. And you're going to enter it there. And what it's going to do is it's going to calculate if your number in K is divisible by 3 or not. So I took out the math. Normally, this is math that computer science students do to learn how to create algorithms. What we're doing here is technically creating a hash algorithm for transactions that we're going to enter into our ledger. So I gave everyone a minute to open that resource, download it and open it. And we're going to start with the first transaction. And as I said, I'm going to enter the information just like you did. So our transactions are for 5 learners in our ecosystem who are going to complete some kind of options. Okay, hold on. So I don't see an option to download the spreadsheet. Okay, so Chuck, I can, how can we do this, Jody? It says view only. Okay, give me a second. So before we get started, I want to make sure that everyone has access. Anyone else having issues?
They should, it says view only, but they should be able to click file, download a copy, and
Okay.
then it should work that way versus attempting to like share or do something like that because it's a view only.
Perfect. Okay. So I'm going to give everyone a few more seconds. If you can just download the file, you should be able to get a copy of it. Thank you. Yes. So yeah, the document is view only, but you have to download and open it. Okay, perfect. Thank you, everyone. All right, so I'm hoping that for those of you who are still trying to download, I'm going to give you another second. As I explain, you'll have some time, so we're not going to do anything yet. So just to explain, we're going to have 5 learners that are going to be creating some type of option that learning activity, and they're going to earn some tokens. So we're thinking about an ecosystem where our learners earn learning tokens that then they can cash out for something else like college credits or something like that in our fictitious company here. So you'll notice here that I have an actor. This is the student. So under this is the student's public key, and it's how the system and the blockchain would recognize that student. You and I would not be able to know who that student is unless we could associate that public ID with someone directly. That student would also have a private key, so then they can look on the blockchain and look at their records and also share that record with someone else. So in this case, what we're going to do is this student, actor AD59DA, completed a cat yoga class, and this cat 609 is the class name or the class ID. And then 10 is the value of the token. So we're going to copy onto our spreadsheet here that information. And for the sake of time, I had entered mine already. So this is what I want you to enter into your spreadsheet. So I want you to enter under the transaction name. I want you to enter cat 609. Under the learner public key, you're going to enter the ADA59DA. And then for the token, you're going to enter 10 because that's how many tokens the learner earned. So I'm going to give you a few seconds to enter that information, and I'll leave this up on the screen also. So again, in the first row 7, which has the block number 1, you're going to enter the transaction name, which is the class name or the class ID, that cat 609. It is, AD59DA. Sorry about that. You're going to enter the information as it appears on the screen and not how my voice translates it. Sorry, a little case of dyslexia there. So AD59DA goes in the learner public key, and then the token is 10. I'll give you a second. What we're doing with this is we are creating a hash algorithm. Okay, so now we're ready. So we're all going to be putting on our miner hats. We're all going to be miners, and our ledgers are actually nodes on the blockchain network and our fake blockchain network. So now what we need to do as miners is we have to solve a puzzle in order to get this specific transaction onto the blockchain. Because right now it's just information, right? Um, so what we need to do is we're going to skip the nonce. So the nonce stands for number used only once. I have heard people tell me that it's a derogatory term in the UK. Sorry about that. I didn't make up the name. Um, that's the acronym that's used for it. It's called nonce. So we're going to skip column F and we're going to jump to column G. So you're going to use the decoder down here to enter a number that aligns to the information that it's asking you for columns G, H, and I, so A, B, C. And what the purpose of this is that in blockchain, the computers only understand numbers and it does not understand letters. So you have to associate a number with a specific letter in order for it to work for you. So in the first one, if we look up the value of the first letter of the transaction, so the value of the first letter is C. So we're going to go down here to our decoder. Think of like a decoder ring or those decoder things that used to come in cereal boxes. It's kind of the same thing. So C equals 67. So you put 67 in box G. Then H is the value of the first letter of the learner key. So the learner key is, the first letter is A, and if we look at that on the decoder, that's 65, so we'll enter 65. And notice that as we enter numbers, under column K, it is appending all those digits together automatically for us, so no math. And also notice that the divisible by 3, or column L, is changing also. So the next value we have to do is the token value, and that's just a straight number. Now, it's asking us for the value of the last 2 digits of the previous hash. So that means it's the value of this one up here on row 0, which would be the last 2 digits, which is 11. So now we have to figure out this random number, which is the nonce, in order to complete our hash or our hashing algorithm, our encryption. So you have to pick a number between 1 and 3. So if we enter, let's say 2, is that correct? That's not correct because the divisible here by 3 is red. So it means that this number 2675651011 is not divisible by 3. So let's try another number. Let's try 1. Still red. So that number is not divisible by 3. How about let's try number 3? Now we see that we have a green box. So this means that our hash is correct. And in the case of mining, what you're doing is you're going for speed. Whoever can solve that puzzle first usually gets what's called the block. So they earn money from being able to solve as many of the puzzles as possible. So now everyone, we would have a consensus, right? So we would review this and we would say, okay, so someone said they figured it out first. Did they get it right? And we had a gameplay of the blockchain game I created, and what happened was it got really competitive, right? So basically, right now we would all say, okay, so the nonce is 3, yes or no. The value of A is actually of column G is actually 67, yes or no. Value of column H, which is the first letter of the learner key, is 65, yes or no. We all agree, consensus, right? We're looking for that. And then the value of the token is 10. And then the last 2 digits of the previous hash is 11, and it is divisible. So everyone should have the same hash. The first one to solve the puzzle would actually get this right. So I'm seeing here Grant just posted a question and asking if x times 3 divided by 3 is always going to, no, it's not correct. So there's formulas in this spreadsheet that will help you go through that, and computers normally do this math. So are we ready for another transaction? Let's see if you guys can do one on your own. All right, so the next transaction. The actor is F, and I'll do it with you guys. FC45E2, and I'll put that in our chat here. So the actor on this one is FC45E2. So put that in your spreadsheet. And this learner actually attended a forklift training course. And the course name is FR, I put the value in the wrong spot. So it's FRK. Let's see if I can write here. FRK 32. The actor is FC45E2, and the value of the tokens is 20. So now let's see if you can figure out. No, so column J will not be 11 at this point. Well, it would be 11 in this case because we have the previous hash here is 11. So in this column, it will always be 11, or in this spreadsheet, it'll always be 11 just because of the order where I put the nonce, because I wanted to put the nonce first. So I see that a few of you got it. Okay, so who can type in what the nonce is? For those of you who got it, let's see. Can you put in the full nonce? So F is 70, right? The next, yep. So the value of the transaction is 70. The learner is 70, and the token is 20. What's your nonce? 3. Okay, let's see. Yep, that worked. Great job. Let's do one more transaction. So we have a consensus because everyone's saying that they got it right. Thank you so much. Let's do the next one. Okay, so in this one, the actor is DA603D. They attended a virtual conference, ATDTK 2022, and they earned 5 tokens. So let's try that one next. Let's see who can, if you solve it first, type got it in the chat and then share the nonce with us. Okay, so I see some got it's and there was the nonce. 1. Okay, let's see. You guys are right. The nonce is 1. So this is how transactions get onto the blockchain. So there's a consensus here. You see the first person who hashed it got it right. They were able to prove that their nonce worked. We were able to validate that work. This is how blockchain works. You guys want to try one more? We have 2 more transactions. Perfect. All right, let's do one more. We'll do the rest of the transactions. So the next transaction, the actor is 67445, and he took a leadership course, or she took a leadership course, and the leadership course is SL234, and they earned 25 tokens because they taught the leadership course. So this is a different approach to it, right? So let's see here. I have mine entered here, and the first one to get the nonce, got it into the chat. All right, let's see. Got it. So they're saying, what's the nonce? 3. So Pedro, you said you think you got it. Okay. Let's see. Philip, you posted it first. So let's see, you say 3. All right, that's also correct. It looks like, so it doesn't look like mine was calculating down here. So let me just copy this down. All right, perfect. And you were right. All right, last one, because then we're going to we're going to see what happens if we try to change something in this blockchain. So let's do one more transaction. Okay, so since they all worked for you, we would have to go through a consensus. In the consensus, it would be however many came up with 1 or 2 or 3. That's that's the number we would all do or use, right? And so in a game, this is where there's the battle of the majority. So I did throw some things in here that were meant for live play because I actually created this for live play and not for virtual play. So we're doing a stripped down version, but this would create a lot of contention in our game to see that all of them work, and we would go with the majority. All right, let's do the last one, guys. So it's this actor or this learner taught a 3D printing class, and they earn 7 tokens. And so the first one to get this one, hold on. Okay, a bunch of got it. What's the number? 1? Okay, so I'm slow here. So we're lucky that the first number is 3. And then B is 66. The token was 7, and I kept the previous hash. Let's see. Mine is saying it is not 1. Everyone else got 1? Maybe I got something wrong. So it's communism. Okay. So it's 3. I think it's 3, guys. So it's first letter. Oh, you're right. Okay, I see where everyone got thrown. So this here, it does say the value of the first letter, but the first digit is actually a 3, so we went with the number. I agree that D isn't the first letter. It's actually, it should have been the first character, but it is the first digit or letter. That was actually confusion, a bit of confusion from my part in here for this game. But the nonce is 3. So what you guys are doing in chat, this is called consensus, right? So you guys are saying like, yes, no, it's this, it's that, right? You all have to come to a consensus and agree. That's what happens in blockchain, is that there's this whole consensus building around like what is accurate in the blockchain. So now, yeah, I know I am changing the rules. So now let's see what happens if we try to change something in the blockchain. So guys, we all got bribed by learner FC45E2. That learner sent us a message and they're saying they're going to transfer 100,000 Bitcoins to us if we can change the value of their token to 10, right? So they want us to change the value of their token to 10, and they want us to change the this transaction number, this transaction code. So they don't want anyone to see that they attended ATDTK. They want everyone to see that they attended CES, right? So what I want you to do is on line 9, so block number 3, I want you to change that to CES, right? And then I want you to change, oops, sorry, it was line 8. It's this guy here. He wants us to think he went to a CES. Sorry, not TK, CES. So we're going to change line 8, the transaction name to CES, and the token, we're going to change it to 10. And then what I want you to do is I want you to just change the information on that line alone. So CES would be 67, right? And then 70 would be for F, and then 10. You can't change the nonce. The nonce has to stay because the nonce is always, that's already been solved for. And so you can't change the nonce. You can only change the information related to the transaction. So the nonce was already solved for by the miners. So yeah, it breaks, right? So what would have to happen in order for this transaction to be changed throughout the entire block on the blockchain? So this block, this person trying to get this transaction changed would have to be able to get all the other transactions changed, which means that that person would need to know what transactions are associated to their transaction on the block, because there's always a reference to a previous transaction, right? As I mentioned, I changed the nonce, so it's at the beginning and not at the end. Normally the nonce is at the end or in the middle, like it's in different segments. I just put it at the beginning for this particular game, just to give you guys a different flavor of it. But there's different ways that those letters and those columns could be organized. So, but they would be the same order for every transaction. So this is where order matters in a block on the blockchain. So if you're trying to change a transaction on this blockchain after it's been committed to the blockchain, right? It's already on the blockchain because the puzzle has been solved. You can't do that. So this is where blockchain is a secure and immutable type of ledger, right? Because you can't just go in and change it. Once it's there, it's committed. And if you try to change it, it breaks. So now let's say I was a bad node, right? Was a bad actor who was trying to hack this blockchain. And I'm like, okay, I'm going to start changing like all of this stuff. I want this to be 50. I'm going to change this to 50. And I want this one to be, I don't know, 25. So I'm going to change this to 25. And I start trying to hack this blockchain. What's going to happen is that my node would get disconnected from the network. I would be blacklisted, right? I would be like, I'd be condemned. I would not be allowed anymore. So this would, the node that's the bad actor would be isolated, and the rest of the nodes, it would not impact the information that's on the other nodes who share the same information. So because my node is trying to force bad information onto a block that's already established, I would be isolated. So let's look at this question. In this example, wouldn't we have a 1 in 3 chance of any edited transactions matching the original nonce? Well, yeah, for this, right, because we're using a number between 1 and 3. In a real hash algorithm, they're using anything between 1 and 9. And so there's still a chance, but because it's already committed, that change needs to be transported to every other block on the blockchain. And there's more than just 5 transactions on a blockchain, right? This block would then get hashed also, like there would be a hash for this block, and it would impact the hash of the block, which is referenced on another block. And so it would be hard to get everything changed across the board. So aren't there other token values that could still work for line 8, like 23? Yeah, there's, like I said, in this specific example, there are other examples that could work. But because all the blocks are connected, right? So when you think of blockchain, it's blocks with chains. It's blocks that are connected to each other and they reference each other. So a block, the first block on the block has information for that specific block, and then a new block is created and it's linked. So then where we have the 0, this would actually be, this references a previous block. So this 11 right here, this hash is the reference to the other block. It would not normally end up at the end of every hash here. It would be somewhere in the middle or somewhere at the beginning. It would be in a different location. And then when the hash is created for the block, it would actually be different, and it would be referenced by another blockchain or block on the blockchain. So definitely an interesting thing. So let's see, how can someone audit blockchain transactions? How are the managers within a given blockchain activities be alerted to tampering? So There are different blockchains out there that you can verify transactions on. So in this case, let me just show you really quick. There's a site. Oh, I'm already on the internet here, or my web browser. We're going to go to blockchain.info. And this is the main blockchain. And on this blockchain, so if you were using this blockchain to issue like certificates or to issue some kind of token or digital asset, you would have to enter either the transaction ID, the student private ID, public ID, or the address on the blockchain, that hash. You would put it here and you would be able to confirm the transaction here. Blockchain is primarily there's another blockchain called Ethereum, and that is a different way that you would actually be able to confirm that. This is just for blockchain itself. Now you can use different platforms to create blockchain credentials, like a Credible and Credly, and they would provide you with a way to verify a transaction. And you should be able to take whatever that hash code is or that ID for that transaction and put it into either a blockchain.info or an Etherscan to look it up. Let's see here some of these questions here before we keep on going. I appreciate you guys playing through the game with me. I hope that you found this interesting and useful. So let's see here for the primary blockchains. Okay, so we already went through that one. Yeah, that's true. So consensus is 51% of the people agreeing, and those mining transactions happen in milliseconds. Like, it is a super fast moving, fast paced kind of game. There's no like, let's solve it and let's stop and let's drink some coffee and think about this. It is super fast. Like, there are computers. So that's why you hear miners using these computers. You need a lot of processing power, which is why people say that, blockchain is not a green technology at all, because it uses so much compute power to be able to validate transactions onto the blockchain. There's also this thing called gas fee. So in order to get a transaction onto, or a digital asset onto the blockchain, you pay a gas fee. And that gas fee can be as low as $5 and as much as $1,000, depending on the asset and the amount of activity on the network at any given time for mining. And there's sites where you can look up gas fees. That's a whole nother topic, and just something really interesting to walk through. So now let's talk about some use cases. So let me see if I can get up here, because I want to make sure that we have some time for general discussion on this. So here are some proposed use cases for blockchain. Now, I say proposed because there aren't a lot of learning organizations that are using blockchain just yet. It's mainly used for issuing like a certificate, right, or a digital badge. But there's so many other different proposed use cases for blockchain that we're going to see it coming down the road as more learning providers create solutions that we can actually leverage. Right now, a lot of this can just be done straight on blockchain. If you can, if you know how to code, and you can, use some solidarity and create your own blockchain. But for right now, if we're looking at commercial use, like for blockchain proposed use cases in L&D, first one is record keeping that's accurate and transparent, right? So as we mentioned, a learner would have access to their own records. They would be able to share that with employers. If they're moving, it goes with them. And everyone that participates in the activity would see the same information. So in this case, the employer, the trainer, the learner, anyone else, that their manager, anyone else that is involved in that transaction would see that transaction and would know that it's validated, right? Because it's not going through just one circuit, it's going through many. The next one is tracking and individualizing learning performance. And so the tracking and individualizing learning performance, I think about competency tracking, right? So that's something that we could really do in blockchain. So if you think about, there is this, and I think it was in 2018. I attended DevLearn, and they had Jay McGonigal. She's a futurist from the Institute of the Future, sharing something about EduBlocks. And EduBlocks is this whole concept where you teach it's a network where I can teach someone a skill. Once they demonstrate the skill, I can issue them an EduBlock that would then be committed to the blockchain, right? It would also be a way of tracking low performance and giving signaling managers where they can identify who needs additional support, right? Whether it's a student or it's an employee or just someone in the community. So there are some potential around that also, because that becomes a permanent record also that someone can see progression also in performance and performance improvement. The other one is providing learning incentives. How many of you struggle with engagement? So engaging learners, that is like a whole other pain point for everyone, right? So how many of you create courses and there's like low learner engagement and people are just like, oh, I have to take this training. I'm one of those people, right? You give me training, I'm like, okay, I'll do it in a minute. I'll do it in a minute. What if we could incentivize learners through blockchain, through tokenization, right? So I'm given a set of criteria through a smart contract where there's a smart contract between me and L&D, and L&D gives me the criteria for things that I need to complete, and I'm rewarded with tokens. Now, those tokens don't need to have monetary value. So I want you guys to kind of think about this a little bit different. It doesn't have to have monetary value, but it will still have value, right? Because it could be that token could be something that maybe I'm getting CEUs for them that I can convert into a college credit, or maybe it's something where I'm getting a token that then together with multiple other tokens would turn into a professional certification that I can take out into industry. So like you can brainstorm tons of applications for this. I think that there's true value in it. And then powering learner accountability, right? So when we think about learner accountability, I'm going to pull up the document that I shared with you guys, that I have for you guys. Let me just see if I can pull it up here. Here it goes. So in the doc I shared with you guys, I just want you to kind of go through. So, part of this learner accountability is through smart contracts also, and holding them to KPIs and things that they need to complete in order to, it can be tied to job performance. It could be tied to bonuses, raises. It could be tied to so many different things, but you would do it using smart contracts on the blockchain. And that way, a smart contract automates a process for you, so you don't have to do all the manual work yourself. So these are just 4 use cases. I'm sure that we can come up with a ton of other use cases for blockchain in learning. Now that you have kind of this baseline idea of what blockchain is used for, right, and what its potential use cases are. I think personally that I get really stoked about the idea of the record keeping and accuracy of and transparency of a learning record, because think about this. When your company hires someone and they do an educational background check, how many stories have we read in the news of people who falsify degrees? Have you guys read any of those? I've read plenty of those, where people in high paying positions falsify the fact that they've had a type of degree or any degree at all. And then it comes out months or years later that they lied, right? If it was a blockchain backed credential, there would be no question about that, because it would be really hard to falsify a credential that's issued by a recognized institution. The same with certifications. Your organization may pay for people to go get certification. They may come back to you and say, oh, here's my certificate. You don't know if it's a forged certificate or not, right? You would go based on their word in the honor system, but with a blockchain backed credential, you're able to verify it. And now not only does the learner own their record because it goes with them, you can actually verify and they can, share it with others. What other potential use cases do you think there are for blockchain? I'd love to hear your put on this in the chat here. And I'm going to read some of these inputs here just to make sure that I don't lose anything here. So Kenneth says attaching a token to credentials would be incredible for higher ed and medical credentialing as it applies to accreditation. Yep. And then Anne says, yes, and for democratizing the value of specific discrete knowledge that has street value outside of a specific organization. That is huge. That's competency, tokenizing competencies, right? So we talk about right now we're in the great resignation and everyone's trying to learn new skills. There are tons of people out there who have skills, knowledge, and abilities that they have no way of validating, right? So we think of validation of competencies right now through like certification or taking a test or whatever it is. But imagine having someone being able to validate a competency with either a blockchain-backed credential, badge, token, whatever it is, right? And being able to have that competency validated by an actual source, a professional source who was able to see the learner delivering that competency in a real work setting, not in a simulated setting, but in a real work setting, and then being able to actually create some currency for competencies. Because we know that, right now what's most valuable are degrees. So bachelor's degrees, master's degrees, PhDs. But imagine being able to add the same value to competencies for someone who doesn't have a degree, but who has a wealth of knowledge and is extremely competent and maybe even more times more competent than that person with a degree. I think there's huge ways to democratize that. Would make auditing and recertification a breeze? Definitely. So let's see here. In practice, would blockchain and learning be public or private? Would this be learner supporting systems that exist outside of an organization and follow through life? Or would it be an organization-centered blockchain? So think about blockchain. So this is a great question. Okay, so blockchain is a decentralized system. Okay, so when you think about decentralized, let me give you some examples of centralized. Your bank is centralized, right? You have a specific bank that you go and you put your money into that bank, and that bank can decide that they want to close your account. All your money's in that one bank, in that one institution. If that institution goes defunct, you may not lose all your money, but the records they have on your equities and whatever kind of assets you have in there may be lost, right? There's a potential for security risk there. With blockchain, it's decentralized, which means that there are multiple computers in a network that have the information that can be validated. So one of those computers goes down, one of those nodes goes down. It's not a big deal because that credential can still be verified because there are other nodes in that network that have a record of that transaction or of that credential. So blockchain should be, like when you think about blockchain, I know that a lot of people are like, oh, we're going to build our own blockchain. You can build your own blockchain, but then you're kind of defeating the purpose of a decentralized network, right? Decentralizing a network means empowering learners to have access to their own records without having to request a transcript, right? Think about that. That's decentralized, or that's centralized. When you have to request your transcript, you have to go to your university, you have to pay a fee, you have to wait forever, and then hope that they send you a transcript. With blockchain, that individual would be able to just go on the blockchain, get their transcript, and say, here's my transcript. And whoever they share it with could validate that it came off the blockchain because it has that blockchain address. So I hope this makes sense to everyone. Let's see. So I have a few more things here. So in your handout, I have this, how does blockchain work? I think what we did with the game and the Excel spreadsheet kind of goes into this, where we talk about everyone having access to the whole of the information. So everyone here and had access to the same information that was put into your spreadsheets. We saw that making changes breaks the blockchain, right? So change to the network or to the block really breaks everything. We used a consensus method for validating your blocks. We know that blockchain is a permanent and secure repository, so we saw that. Because it is shared across various nodes in the network, that information becomes very secure, right? Because there's no PII, first of all. So no one's sharing personal information. Everything's encrypted. And in order for someone to gain access to the blockchain, once the information is encrypted, they need a private key. So they need that username and password to be able to gain access to it. And that username and password could be shared, not the same username and password, but like two people with two different private and public keys can gain access to the same information to validate it. There is a public key that's all you need to validate. And so once someone has that public key, they can go in there and validate the transaction. The block can't be undone, and we saw that. Members of the blockchain community can see the entire history. So, that blockchain.info site right here, we can see every transaction ever done on the blockchain here. But we do need to know what the hash is. We may need to know what the transaction ID is, or the address, like a wallet address. We didn't go into wallets today. Wallets are basically where you keep your information. It's a digital wallet. It's like a physical wallet, but it's digital, right? And it's secure. You need that public and private key to be able to access it. And it's different. It's a different public and private key than you would have for the transactions also. Here we can see, so if we kept an eye on this blockchain here, we can see what the transactions are. There's some amounts. These are all like crypto trading, but we can also see who the miners are. Some miners are named, most of them go unknown. So you can go through here and really look through the different charts to see like what's going on the blockchain, and finding a blockchain address or a transaction ID and entering it here to see if it appears on the blockchain. A great way to do this is if you're using Credly or Credible, you should be able to take that address that they give you and plug it in here to verify that the transaction's on the blockchain. So we have 8 minutes left. So I want to see as I mentioned, I wanted to get everyone into Mural, but with the platform, I'm just afraid of breaking things. So we're not going to jump into Mural today as I thought originally. And I apologize for that switch, but I want to see what types of questions do you have right now. So we have 8 minutes for questions and 7 minutes for questions. I want to see what types of questions do you have. You can put it in the chat, or ideas or thoughts that you have. Jody, are there any questions in the Q&A? I'm going to look right now because it looks like there's a few. As everyone's putting information in.
Yeah, it looks like you have a few in there. Do you want me to read them to you, or do you?
No, I can read them. I'll read them out loud. Thank you. So the first one is, in practice, would blockchain in learning be public or private? I think we answered that one, right? So nothing is public on blockchain. You do need to have the public ID for the transaction or for the individual to be able to verify. So nothing is public. Everything's secure and encrypted. Let's see. What is the incentive for miners to compute the algorithm in a learning blockchain ecosystem, whether the token is powering it has? So to the miners, it makes no difference, right? They are solving puzzles. They don't know what type of transaction it is, whether it's cryptocurrency or if it's a badge that's been issued or whatever it is, because everything is encrypted. So what they're doing is they're solving for the nonce. They're not really solving like we did where we put all that other information in. They're given that information is already given to them. What they're solving is for the nonce. So that number that we did between 1 and 3, that's what miners are trying to solve for. They're trying to solve it super fast. So they're in a competition against each other to solve for that. So there's no concern that you're not going to get the right amount of miners to actually validate a transaction, because to them it's all the same. Hope I answered that. Hold on. Do learning record store use blockchain? Right now, I don't know of any learning record store that uses blockchain. So learning record store are XAPI based, and they're just pulling information from XAPI statements, and they're storing it in a database. That database could potentially be put on the blockchain, but right now I don't know of any providers that are offering a blockchain-backed learning record store. That's interesting though. Who wants to start a new business? Let's see. Jody, can I, once I answer a question, can I mark it answered? I see. Okay, I think I can. So let me just mark some of these answered so I can make sure that I don't go through. So let's see. The next question. And I'll check on the regular chat too soon. What's the simplest implementation of this in L&D? So right now it would be digital badging through a provider like Credly or Credible. That is a great entryway into the whole blockchain-backed credentialing, just to get your feet wet, right? So if you're already doing digital badging, you might want to look at these providers, or if maybe you're already using the provider, you can talk to them about the blockchain-backed credential or, or digital badge. I think that's a good gateway into getting your feet wet with it, because it doesn't require you to do anything other than request that you use the blockchain-backed version. Let's see. Is this expected to replace or mimic a SharePoint type? Never. Yeah, this will never replace a SharePoint. Because you're not storing information that you're sharing back and forth. What you're storing is transaction information, which is very different. So think of it as an accounting book. Think of it as a learning record store, but where everyone else has access to it, as long as they have that public and private key to gain access to the information, and the information is being put onto the blockchain itself. I'm trying to get these in order, so just bear with me because I see a few more just came in. How can NFTs be utilized in L&D? So how much time we have here? We have 3 minutes. I'm going to save that one for last because I can go on a whole rant about NFTs and how they can be leveraged for learning assets, digital learning assets, because there's huge potential there. But let's move on to the next question. Could we pull the data learning accomplishment automatically to recognize that for personalized learning paths or incentives? So this would require, you would not be pulling data. What you would do is you would use a smart contract so it can signal if someone, like kind of what the path is for someone. The smart contract would just have the criterias that need to be met or not met in order for something to be signaled. So something that's automated, so you don't pull anything through the smart contract. In the definition, you would actually establish those criteria and it would do some signaling. You can have it send like a notification out for specific things. And so that's a little bit more complex of a system that we don't have built just yet for L&D. And I hope that answers your question. Let's see. Could I have 2 platforms to access for my blockchain transactions? You could. Let's say you're using Credly and you want to use the blockchain.info. You would still enter the same information to verify that the transaction is actually there. It all depends on which blockchain you use. Is it a Bitcoin transaction or an Ethereum transaction? That's the most important part, because you can't verify an Ethereum transaction on blockchain, and you can't verify a blockchain transaction on Ethereum because they're two like different worlds. And let's see. So the NFTs. So I actually have 4 minutes, guys. So let's talk about NFTs for learning. And I'm going to go back to chat also and see what else is there. So for NFTs, because you put the question in here also, Dane, I am a big fan of NFTs right now, but not for the way that most people see it. So I do have NFTs I've created and they're out there. I use SoulSea. It is art, but there's a whole nother potential for NFTs. So you can NFT just about anything. For those of you who don't know what NFT is, it's a non-fungible token. So I'm going to put that in here in the chat. So NFT. So non-fungible token think of it as it's just a digital asset, and it's not the actual asset itself. It's just that it's that algorithm that creates that asset and it puts it onto the blockchain or onto the Ethereum chain or whatever other Polygon. There's a bunch of different networks that you can list on, and that's a whole nother conversation. And I don't want to confuse everyone too much, but you could NFT. Let's say you create a training package that your company wants to source out to other companies, right? Because it's so great. It's like an amazing learning solution. You could NFT that solution and other people could license it from you as an NFT, meaning they get access to that NFT that you created, and you can see who is using that NFT, who has ownership, who has rights. So the moment there's someone out there who's using your stuff, you can look on your blockchain and see that person didn't get it from you, and then you can do some recourse or whatever. But with learners, you can also have them, incentivize them with owning a part of something, right? And let's say it's creating a training for subject matter experts, which we all have an issue working with sometimes because they're so taxed for time. You could actually give a subject matter expert a portion of that NFT, meaning you can have one course that has, you've minted 10 times, and minting just means putting it onto a blockchain. You've minted 10 times, and so you give them one of the 10 mints, so then they own a piece of that. And if you ever sell that, they could get royalties or whatever, a way to incentivize. It's convoluted. And I think that's a whole different conversation in itself. I can go on forever. And I just don't want to confuse you guys too much. I already feel like I may have inserted some confusion in here. So any additional questions? I need to take a sip of water here. I'm going to read through this. All right. I don't see any additional questions, Jody, and we are down to, are we overtime, Jody?
Yes, we are. Thank you so much for such an exciting session. It definitely was above me, but I loved every minute of it. I learned a lot. So thank you very much.
Thank you so much, guys. And thank you for hanging out with me and for your great questions. I appreciate you guys so much. Download that spreadsheet. Download the resource. Connect with me on LinkedIn. I'm always open to answer questions.